What if the universe just proved that even a black hole can be thrown away? And what if the thing, now racing through deep space, is not only surviving, but creating a trail of new stars behind it? Before we dive in, hit like, subscribe, and share this with one person who loves space stories that feel too wild to be real. That sounds impossible, because black holes are supposed to be the final destroyers. They crush, they swallow, they erase. When most of us picture a black hole, we picture a dark mouth in space, pulling everything inward and giving nothing back. So the idea that one of them could be moving alone between galaxies, with no home, no orbit, no safe center to sit in, already feels strange enough. But then comes the part that pushes this story over the edge. Behind it stretches a thin, glowing line of newborn stars, like the universe itself drew a scar across the dark. The object at the center of this mystery appears to be a supermassive black hole with a mass around 10 million times the mass of our sun. It is not drifting slowly. It is moving at roughly 1,000 kilometers per second, which is about 2.2 million miles per hour. At that speed, it could go from Earth to the moon in minutes. It could cross distances that make our whole solar system feel tiny. And it seems to have been doing this for tens of millions of years. Now, pause and think about what that means. A black hole that massive is not some loose rock kicked out of a backyard. This is the kind of object that usually lives in the center of a galaxy. It is supposed to sit in the deepest gravitational well, where billions of stars orbit around it, where gas, dust, light, and sometimes entire star systems get dragged into its reach. To throw something like that out of its own galaxy takes violence on a scale that is hard to put into words. And yet, that is exactly what astronomers now believe happened. This story did not begin with anyone searching for a runaway black hole. It began the way many great discoveries begin, with someone looking for one thing and finding something completely different. A team of astronomers was studying old Hubble Space Telescope images. Their original work had nothing to do with this mystery. They were examining a distant system and doing the kind of careful image review that fills much of real science. Not every discovery begins with a dramatic mission. Sometimes it begins with patience, old data, and a human being noticing that something looks wrong. In one image, there was a long, narrow streak of light. Not a fuzzy patch, not a curved arc, not a spiral shaped like a galaxy, a nearly ruler straight line. It was so strange that the first simple explanation had to be an error. Space telescopes often get hit by cosmic rays, tiny high-energy particles that strike the detector and leave fake bright marks on the image. If you have ever seen an old photo with a scratch, it is a bit like that. Astronomers know this problem very well, which is why telescopes usually capture multiple exposures of the same area. So the team checked. If the line appeared in one image and vanished in the next, then it was probably just a cosmic ray hit. Mystery solved. But that is not what happened. The streak was still there. Same place, same direction, same unsettling shape. That meant it was real. And once it became real, it became a problem. Because nature does not usually draw giant straight lines across intergalactic space. Galaxies have structure, but that structure bends and spreads. Gas clouds twist. Jets from active black holes can shoot far into space, but they widen, ripple, and interact with their surroundings in ways that usually make them messy, not clean. Even when the universe creates something dramatic, it rarely creates something this narrow, this long, and this direct. The streak seemed to point back toward a distant galaxy system, almost like evidence left behind after a cosmic escape. The farther astronomers pushed the normal explanations, the less satisfying those explanations became. Could it be an edge on galaxy, seen from exactly the right angle to look like a line? The brightness profile did not fit. Could it be a jet? The structure did not behave like one. Could it be some odd instrumental effect? The repeated images argued against that. One by one, the safer answers became harder to defend. That is when the dangerous idea stayed alive. What if this was the trail of a black hole that had been launched out of its galaxy and was now plowing through gas, far beyond the place where it was born? That idea had existed in theory for decades. Physicists had long known that under extreme conditions, a supermassive black hole could be kicked out of a galaxy. But knowing something is possible on paper is not the same as seeing it in the sky. The universe does not always give us clear examples of its strangest behaviors. Many predictions wait for years, even generations, before a real object appears that can test them. And this object was strange enough that Hubble alone could not finish the job. Hubble could show the line. It could reveal that something unusual was there, but it could not fully answer the most important question. What was happening at the leading edge of that streak? If a giant black hole really was punching through thin gas at extreme speed, then the gas in front of it should show signs of being slammed, compressed, and heated. In other words, there should be a shock front. That is where the James Webb Space Telescope entered the story. Webb is famous for its breathtaking images, but some of its greatest power comes from what it can measure, not just what it can photograph. Using spectroscopy, Webb can spread light out into detailed information. It can tell astronomers how gas is moving, what it is made of, and how violently it is being disturbed. It can look at a patch of light and reveal whether that light is calm, chaotic, hot, cold, rushing toward us, or racing away. So Webb looked at the tip of the streak. And what it found was the kind of evidence scientists dream about. Right at the front, the gas showed a sudden, sharp jump in velocity, on the order of hundreds of kilometers per second packed into a small region. That kind of jump is exactly what you expect when something massive is driving a bow shock through surrounding material. Think of the wave that forms in front of a speeding boat. Think of the pressure wall in front of a supersonic jet. Now scale that up to intergalactic space, where the moving object is not a plane or a boat, but a black hole weighing millions of suns. This was the missing fingerprint. The line was not just a random feature. The front of the line was physically active. Gas there was being violently shocked. The geometry, the motion, and the energy all pointed in the same direction. The simplest explanation that fit the evidence was also the wildest one. Astronomers were looking at the first directly confirmed runaway supermassive black hole, identified through the shock it created as it tore through gas between galaxies. If that sounds dramatic, the scale makes it even harder to absorb. The glowing trail behind this object stretches for about 200,000 light years. That is wider than the Milky Way. Let that sink in. Our galaxy feels huge because it contains hundreds of billions of stars, and distances so large that light takes 100,000 years just to cross it. And yet the trail behind this fleeing black hole is even longer. It is like watching a single act of violence write a line across space, bigger than the galaxy we live in. And the line is not dead. It is full of star formation. This is the part of the story that people remember because it seems to break the role black holes are supposed to play in our minds. We think of them as endings, endpoints, cosmic traps. But here, in the wake of this one, new stars appear to be forming. How can that be? The answer begins with something many people never think about. The space between galaxies is not truly empty. It is unimaginably thin compared with the air around you, and even compared with the rich gas inside galaxies, it is sparse beyond belief. But it is not nothing. Around galaxies and between them, there is diffuse gas, sometimes called the circumgalactic or intergalactic medium. Most of the time, if something moves through that gas gently, almost nothing visible happens. But gentle is the last word that applies here. A black hole moving at around 1,000 kilometers per second does not simply pass through that medium. It hits it faster than the gas can respond. The gas in front gets compressed and heated. Pressure rises. A bow shock forms. The material is disturbed, squeezed, and pushed. Then, behind the moving object, conditions can change in ways that help parts of that gas cool and collapse. Over time, dense clumps can form. And when those clumps become dense enough, gravity does what gravity always does. It starts building stars. So the black hole is not creating stars with magic. It is creating the conditions that allow star formation to happen in its wake. It is less like a painter and more like a plow cutting through a field, violently, destructively, but in a way that leaves behind a pattern where something new can grow. That is one of the deepest reasons this discovery matters. It reminds us that in the universe, destruction and creation are often tangled together. Supernovae destroy stars and spread the ingredients for future worlds. Galaxy collisions tear systems apart and trigger bursts of new star birth. And now a runaway supermassive black hole seems to be doing something equally unsettling. It is turning a catastrophic ejection into a ribbon of possible life-making material across the dark. If you are still with me, press subscribe and drop a comment with the word runaway, because the universe is getting weirder every minute. But that still leaves the most brutal question of all. What could possibly throw a supermassive black hole out of a galaxy in the first place? The answer is gravity. Not the calm, gentle version of gravity we feel when a dropped cup hits the floor, the savage version, the kind that appears when entire galaxies merge and when black holes circle each other in the final stages before collision. There are two leading ways this can happen. The first is a three-body gravitational encounter. Imagine two galaxies merging. Each galaxy may bring its own central supermassive black hole. Those black holes sink toward the center of the newly forming galaxy and begin orbiting each other. Now imagine a third galaxy joins the chaos before the first pair fully settles. Suddenly, you do not have two giant black holes. You have three. Three-body systems are famously unstable. They exchange energy in unpredictable ways. Usually two of the bodies end up in a tighter pair, and the third gets flung away. On the scale of black holes, that fling can become a true gravitational slingshot. The lightest member of the trio is often the one ejected, and if the energy transfer is strong enough, it can be launched so fast that the entire galaxy loses its grip on it. That alone sounds extreme, but there is an even stranger mechanism. The second possibility happens when two supermassive black holes actually merge. When black holes spiral together and combine, they release gravitational waves, ripples in space and time. We have already detected gravitational waves from stellar mass black holes. With observatories like LIGO and Virgo, those discoveries changed physics, but supermassive black hole mergers involve vastly greater scales. Now here is the key detail. If the two black holes are not perfectly matched in mass and spin, the gravitational waves they release may not be balanced in every direction. More energy can be beamed one way than another, and when that happens, the newly merged black hole receives a recoil kick in the opposite direction. It is the same basic logic as a cannon pushing backward when it fires, except the thing being thrown around is space-time itself. Under the right conditions, that kick can be enormous. Simulations have shown that recoil speeds can reach the range needed to send it flying out of its host galaxy. That may sound like science fiction, but it follows from the same general relativity that has passed every test. In other words, the universe may literally use gravity waves as a cosmic gun. For the object in this story, researchers have worked backward from its apparent speed and behavior to reconstruct what may have happened. The best models suggest an ancient black hole merger with the right mix of mass difference and spin alignment could have launched it, tens of millions of years ago. That means what Webb is helping us see now may be the aftermath of a collision that happened long ago. Long before humans existed, long before Earth looked the way it does today. Think about the chain of logic there. Astronomers observe a glowing line far across the cosmos. They measure shocked gas at the front. They estimate the speed of the object. Then they run the physics backward and infer the kind of black hole merger that could have created the kick. We are not just observing a strange object. We are reading the fossil trace of an event written into the structure of space. And the timing makes the whole thing feel even more unreal. The black hole seems to have been traveling for roughly 70 million years. That is long enough for mountains on Earth to rise and erode, for species to appear and vanish, for continents to shift. During all that time, this object may have been racing onward through the dark, leaving a growing line of disturbed gas and stars. So why are we only noticing it now? Because it was almost invisible. That may be the most unsettling part of the entire discovery. This object was only found because of a lucky combination of circumstances. It passed through gas thick enough to light up. The trail happened to be aligned in a way we could notice. Old Hubble data happened to catch it. Someone happened to look closely. Webb happened to follow up. If any link in that chain had broken, the object might still be hidden from us. And if one runaway supermassive black hole can hide this well, how many others are out there right now? That is not just a dramatic question for a video. It is a serious scientific problem. Galaxies have been colliding and merging for most of cosmic history. If black hole ejections are a natural outcome of some fraction of those, then the universe may contain many rogue supermassive black holes traveling far from the places where they were born. Most would be dark, most would have no bright trail, most would move through emptier regions where there is too little gas to reveal them. They could be crossing intergalactic space completely unseen. That idea changes the emotional picture of the universe. We are used to thinking of galaxies as cities of stars anchored by a black hole in the center, stable, structured, connected. But this discovery adds a darker possibility. Some galaxies may have lost their central black holes. Some black holes may have become cosmic exiles, separated from the systems they once ruled. Not destroyed, not dormant, just gone. That matters because supermassive black holes are not minor details in galaxy evolution. Their growth and activity affect star formation, gas flows, and the behavior of galactic cores. If some galaxies can lose them, even rarely, that adds a whole new branch to the story of how large structures in the universe evolve. It also means we may need to think differently about where black holes can exist, not only in galactic centers, not only in binary systems, not only as quiet monsters waiting in familiar places. Some may be out in the dark, moving alone, carrying a record of catastrophe. And this is where the Webb confirmation becomes bigger than one shocking object. It turns a long-standing theoretical idea into a real population we may one day study. Once you confirm one case, you stop asking, can this happen at all? And start asking, how often does it happen? What kinds of mergers produce it? How many are visible? How many are hidden? And what does that mean for the balance of matter? Future observatories may help answer that. Wide field missions that can scan huge areas of sky could search for more strange linear features. New surveys may reveal more trails, more shocks, more signs of violent ejection. And future gravitational wave observatories, especially those designed for mergers, may detect the collisions capable of launching these. So, in a strange way, this one object connects several frontiers of astronomy at once: archival imaging, infrared spectroscopy, galaxy evolution, gravitational wave physics, star formation, black hole dynamics. It is not just a curiosity, it is a bridge. between fields that are all trying to understand how the universe behaves under its most extreme conditions. Quick pause before we go deeper. If this story is blowing your mind, send this video to your smartest friend and subscribe now, because the next few minutes make the universe feel even less safe and far more beautiful. One reason this discovery feels so powerful is how it was found, not with a dramatic warning, but with a discomfort, a shape that should not be there, a signal too sharp to dismiss, a result that survived every attempt to explain it away. Now step back from the details and picture the scene itself. Far from any familiar galactic center, a black hole is moving. A black hole with the mass of 10 million suns is moving through thin gas at roughly 1,000 kilometers per second. In front of it, the gas is compressed into a violent shock. Behind it, matter is cooling, collapsing, and lighting up in new stars. The trail stretches across 200,000 light years. No planet near it, no bright galactic disk around it, just a dark engine racing through the void with a luminous scar behind it. It sounds less like astronomy and more like myth. But myth is usually a way humans try to describe powers larger than themselves. And every so often, science uncovers something that makes myth modest. Because this object is not simply big, it is lonely. That may sound like a strange word to use for a black hole, but listen to what the evidence implies. It had a home once. It likely sat in a galactic center, surrounded by stars moving in deep time. Then some catastrophic interaction took place. A merger, a recoil, a slingshot. Whatever happened, the result was permanent exile. It was thrown clear of the place that formed it, and for tens of millions of years it has moved through regions where nothing lives. When we talk about space, we often focus on brightness, nebulae, galaxies, explosions, but the larger truth is darkness, vast distances, long silences, empty stretches so huge that human language fails to make them feel real. And through that darkness, this object travels, traveling not for days, not for centuries, but for epochs. That is one reason this discovery hits emotionally, even if you do not care about physics. It takes a concept that already unsettles people, the black hole, and removes even the one thing that made it feel placed. It is no longer sitting in the center of a galaxy where our minds expect it to be. It is wandering, and wandering things make the universe feel less fixed. They remind us that cosmic order is not as calm as textbook diagrams suggest. Galaxies are not frozen islands. Black holes are not always obedient anchors. The universe is dynamic, collision-driven, and brutally unstable. What looks settled on one time scale may be temporary on another. This matters for another reason too. If runaway supermassive black holes are real and not incredibly rare, then some of the assumptions built into our models need adjustment. How often do galaxies temporarily lack a central black hole after mergers? How much star formation can a rogue black hole trigger? Could some isolated star clusters have roots in events like this? Could there be signatures we have misunderstood because we did not expect this? Science often advances by opening questions, not closing them. And this discovery opens a lot. It opens questions about hidden populations, about merger rates, about recoil physics, about the environments that allow such objects visibility, about how much of the universe's violence goes unseen because the background is too dark and the gas too thin. It also sharpens our sense of how incomplete our map still is. We like to think that with modern telescopes, the sky is mostly known. That is not true. The sky is full of processes we barely understand. Sometimes an entirely new category of object waits inside data, waiting unnoticed until someone asks a better question. This is why telescopes like Webb matter so much. They do more than take stunning images for posters and screensavers. They let us test whether impossible-looking features are revelations. They let us read motion inside light. They let us connect form to physics. And sometimes they let us watch theory become reality. There is something else almost poetic here. The black hole was likely launched by a moment of imbalance. Energy went one way, remnant the other. A tiny asymmetry, scaled up through extreme gravity, may have changed the fate of an object millions of times more massive than our sun. That should humble us. In the deepest laws of nature, symmetry matters. Imbalance matters. The direction of spin matters. The angle of a merger matters. Small differences can decide whether a black hole stays enthroned in a galaxy or gets banished into the void. And once it is gone, it may keep moving for longer than civilizations last. So what should we take from all this? First, that the universe is more creative than our categories. We tried to place black holes in one role, destroyer, but nature gave us creator. We tried to place supermassive black holes in one location, galactic centers, but nature gave us one in exile. We like clean rules, but the cosmos prefers exceptions that reveal deeper rules underneath. Second, that astronomy is entering an era where these once theoretical edge cases may become detectable. One confirmed object can lead to a search strategy. One search strategy can lead to a sample, and once you have a sample, mystery becomes science. Third, and maybe most powerfully, That discovery still depends on wonder, not vague wonder, disciplined wonder, the kind that notices what does not fit and refuses to look away. That is the same spirit that has carried astronomy from ancient skywatchers to space telescopes orbiting far beyond Earth. A willingness to stare into the dark and ask whether the dark is hiding a pattern. And in this case, it was. A line too straight to ignore, a shock too strong to dismiss, a black hole too fast to hold, a trail too bright to explain with old assumptions. If this has you rethinking your place in the cosmos, like this video, subscribe for the next deep space story and share it with someone who still thinks the universe is quiet. Because quiet is not what this story says. The story says that somewhere out there, far beyond the scale of anything human, gravity became so violent that it threw a supermassive black hole out of a galaxy. It says that the exile did not vanish. It kept going. It says that as it moved, it carved a path through gas and helped ignite stars in its wake. It says that for tens of millions of years, this event was unfolding in silence while life on Earth went about its fragile business. And only now, through old Hubble images and Webb's deeper vision, are we beginning to understand what we were seeing. That is the part I cannot get over. Not just that the universe did something this extreme, but that it left the evidence waiting there until we were finally capable of reading it. The runaway black hole is not just a monster in motion. It is a message from cosmic history. A reminder that the universe does not freeze itself into forms that make sense to us. It collides, recoils, ejects, builds, destroys, hides, reveals. And every now and then, it shows us something that rewrites the emotional map in our heads. A black hole without a galaxy. A trail of stars where there should have been only ruin. A straight line across the void like the signature of an event so violent that even space could not smooth it away. That is why this matters. Not because it is a cool headline, not because it sounds dramatic in a thumbnail, but because it reveals a universe that is stranger, harsher, and more alive than the simple version we carry around in our minds. Somewhere in the deep dark, a black hole is still running, and the stars behind it are still telling the story.